Hello and welcome to the Next Generation Science Standards, Analyzing Interpreting Data Using Mathematics and Appendix L Connections to Mathematics module. Today, teachers will be introduced to and become familiar with the Next Generation Science Standards Appendix L, which is Connections to the Common Core State Standards for Mathematics. Teachers will also explore Appendix D, All Standards, All Students, for strategies and implementation ideas when teaching the next generation science standards to a diverse population of learners. Before we begin, think about why we should connect. Why do you believe it is important to have cross-curricular connections between science and math standards? List 2 obstacles that can impede effective teaching and learning of the next generation science standards with math connections. When you are done with these 2 questions, please give one, get one with a neighbor to compare your responses. What Appendix L will do for you. The Next Generation Science Standards Appendix L aims to provide educators with an accurate timeline of mathematical expectations of students so as to prevent misalignment or outpacing of the Math Common Core State Standards. This is a convenient way to ensure that we teach mathematical concepts at or after they appear in the Math Common Core State Standards. We'll start by visiting the Next Generation Science Standards website. Please type in nextgenscience.org into your web browser to view the site. On your screen, you should see the Next Generation Science Standards homepage. When you are here, please click on the Next Generation Science Standards tab at the top of the homepage. If you scroll down on this page, on the left-hand side you will see red appendix tabs. Please click on L, Connections to Common Core State Standards Mathematics. Now that you have clicked on the Appendix L link, a PDF of the Next Generation Science Standards Appendix L, Connections to the Common Core State Standards for Mathematics, should come up. As it states in this document, science is a quantitative discipline, so it is important for educators to ensure that students' science learning coheres well with their learning in mathematics. The goal of Appendix L is to provide an accurate timeline connection for teachers to bring mathematical practices into the science curriculum. If you scroll down this page, you'll notice a table at the bottom of page 1. This table shows the key topics relevant to science taken from the Common Core State Standards for Mathematics. It also shows the grade in which it's first expected to appear in the Common Core State Standards for Mathematics curriculum. For example, the coordinate plane, which has ties to the science curriculum, is first expected from the Common Core State Standards for Mathematics in grade 5. Please take a moment to look through this table and note any key topics that might be relevant to your particular science class, and note the grade that the concept is first expected based on the mathematics curriculum. After you have looked at Table 1, scroll down to page 2. For additional information on representing and interpreting data in grades K through 5, or for additional information on measurement in grades K through 5, you can click on the 2 progression documents. These go over the Common Core State Standards for Mathematics. Further down the document, you will notice Table 2. These are middle school and high school science and engineering practices that require integrating the Common Core State Standards for Mathematics, math, and statistics tools into the Next Generation Science Standard aligned instructional materials and assessments. Please take a moment and look through Table 2. When you are finished looking through Table 2, continue to scroll down to the Connections to the Common Core State Standards for Mathematics Standards for Mathematical Practice. This document outlines the 3 Common Core State Standards for Mathematics practice standards most directly relevant to science. They are MP2, reason abstractly and quantitatively, MP4, model with mathematics, and MP5, use appropriate tools strategically. These three standards mean different things based on the grade levels involved. For example, for MP2, in kindergarten, students might use a symbolic statement like 6 is greater than 4. However, a middle school student might rewrite the equation d equals 65 times t for the motion of a car in the equivalent form d divided by t equals 65. While a high school student might connect the 2 in the equation n equals 2 to the nth power to the fact that each dividing cell gives rise to 2 daughter cells. Please read through the same differentiation by grade level for the second standard, MP4. Make sure to focus on the expectations for K2, 3-5, 6-8, and high school. Finally, we can look at the third standard, MP5, which refers not only to technological tools but also to such strategies as drawing diagrams from kindergarten onwards, and in later grades using well-known formulas and powerful representation schemes like the coordinate plane. These tools and the skill and judgment to use them well are important for quantitative work in science. Now that we have completed the overview of Appendix L, please scroll down. As you can see here, the remainder of this appendix collects together the remaining connections from the connections boxes. Illustrative science examples are provided for a number of the connections along with alignment notes in selected cases. The alignment notes are what is going to align the next generation science standards to the Common Core State Standards for mathematics. Let's take a look at the first standard aligned together. We are looking at KPS2, motion and stability, forces and interactions. As part of this standard, students should be given opportunities to use direct measurement. As you can see, the actual standard is written here. Describe measurable attributes of objects such as length or width. Describe several measurable attributes of a single object. And the second standard, directly compare two objects with measurable attributes in common to see which one has more of, less of the attribute, and describe the difference. As you can see, for this specific standard, science examples are given. These illustrate potential examples that students can do in the classroom to achieve this standard. As you can see, this particular standard also has alignment notes. So these notes tell us the alignment to the Common Core State Standard for mathematics. So remembering here that we are looking at a kindergarten standard, we want to make sure not to include standards from the mathematics curriculum that are learned in grades 1 and beyond. So here we have a list of 2 items to make sure not to include while teaching this kindergarten standard. The first, data displays such as picture graphs and bar graphs are not expected until grade 2. And the second, standard length units such as centimeters or inches are not expected until grade 2, while informal units are not expected until grade 1. Please scroll down to the next kindergarten standard, from molecules to organisms, structures, and processes. Please read through this standard, noting the science example and alignment notes. At this point, we'd like you to complete the alignment activity. Please scroll through Appendix L to find your grade level Next Generation Science Standards. Take note of the illustrative science examples and the alignment notes that are provided for you in this document. Record any informational pieces that will help you in your planning and preparation for teaching the Next Generation Science Standards curriculum. Now that you have completed analyzing the alignment of your Next Generation Science Standards to the Common Core State Standards for Mathematics, please share your findings with a neighbor. Now that we have finished exploring Appendix L of the Next Generation Science Standards, the connections to the Common Core State Standards for Mathematics, we can take a step back and look at the Next Generation Science Standards Practices Venn diagram. In this PDF, we see the commonalities among the practices in science, mathematics, and English language arts. Take a moment to identify the similarities and differences between all three subject areas. This document also shows the practices in mathematics, science, and English language arts separated by subject area. Please take a moment to explore this document. For the second half of the module, we are going to be looking at Appendix D, All Standards, All Students. If you could go back to the homepage, nextgenscience.org, click on Next Generation Science Standards, and then on the left-hand side, scroll down until you see Appendix D, All Standards, All Students / Case Studies. Please click on that appendix. What you should see on your screen is Appendix D, All Standards, All Students, making the Next Generation Science Standards accessible to all students. This document provides teachers with great resources and tools regarding making the Next Generation Science Standards accessible to all students. First, it gives an overview of non-dominant student groups and what that means. It also provides learning opportunities and demands for all and how we can implement those demands in our classroom. It provides an implementation guide for effective strategies. And it gives context to what a diverse population of students means in the American school. It also provides conclusions and implications for making the Next Generation Science Standards accessible to all students. Along with Appendix D, there are 7 case studies that we will be looking at today. For this activity, please scroll down. On page 3, you'll see the overview of the case studies that are available to us through Appendix D. Please identify the case study that is closest to your grade level. This will be the case study that you are going to use for the following activity. For example, if you teach first grade, you should choose students with limited English proficiency, as second grade is the closest grade to first grade. This is a great document to come back to after this module is completed. However, for the time being, we are going to move on to the case studies available. Now that we've looked at a brief overview of Appendix D, please go back to the nextgenscience.org homepage, click on Next Generation Science Standards, and then next to Appendix D, All Standards, All Students, you're going to click on Case Studies. Please identify the case study that you previously identified in Appendix D and click on that case study. As a reminder, the 7 case studies are listed here. So once you have identified your case study and you have clicked on that case study, I'm going to look at case study 1 as an example. Please complete the following activity based on your own individual case study. The case study activity you are going to complete has 4 parts. First, you're going to read through the case study, paying close attention to connections to the Common Core State Standards for Math. 2, please note any connections that stand out to you. These could be connections to the math standards, to the ELA standards, or just connections to your specific non-dominant student group. 3, identify at least 3 strategies that were effective within the case study that you are researching. 4, Using at least one of the 3 strategies you identified in number 3, create an outline of a lesson you could implement in your own classroom that would reach a specific non-dominant student population. For this case study activity, try to use a science standard that can incorporate a math standard in order to apply your knowledge of Appendix L. You can always refer back to Appendix L for ideas. Also, collaborate with your neighbors, as they will have differing perspectives based on the case study they researched.